This is Doughboy and Little Hoodie.
And this is our DNA replication video.
This is the helicase that was hit very fast and is unzipping the two DNAs unzipping the original DNA into two individual strands. While this is occurring, single-stranded binding proteins are getting attached to each strand of the DNA so they don't come back and stick together.
At the very same time, we also see that more additional relaxation of the DNA must happen. And that's where the topoisomerase comes in and relaxes the entirety of the DNA strand. The next step is for the RNA primer to be laid down. This happens through the primates. This will go from the 3' to the 5'. And as you can see, it lays it down. And the reason why we need this RNA primer is it indicates to the cell where it's going to start building the DNA.
So once the primer is set down, this is a good indicator for where the DNA polymerase can come in and start to transcribe. This is our DNA polymerase 3 because it goes on the leading strand on the top. And on the bottom side, it's the lagging strand as the DNA polymerase 1 starts from the 3 side to the 5 side. What's important to note right here is that DNA polymerase only functions from going the 5' side to the 3' side. So polymerase 1 goes right to left from 5 to 3, and DNA polymerase 3 goes from 5 to 3 as well.
So once this happens, what now needs to happen is that the actual DNA needs to be laid down. But the issue with this is that because the DNA polymerase on the lagging strand always goes from this side to this side, and the helicase is still splitting the DNA in this direction, this is always going to need to have to race up to the end, and that's why it's called the lagging strand. Whereas DNA polymerase 3 does not have this issue. It can simply keep on going down the DNA strand. It doesn't really matter if the helicase keeps on going.
So to animate this for you guys, as the DNA polymerase 3 keeps continually going down this side, it creates a transcribed RNA strand right here. And remember, it doesn't need to make any breaks, so it just makes one continuous line. But however, polymerase 1 on the other side, it transcribes 3 and then makes one segment. And then another primer needs to be set down by the primase. So it tells the polymerase to come back in, and then it makes another strand right here.
These fragments that you see right now that need to be stitched together are called Okazaki fragments.
So now we have two duplicated RNA strands, but the Okazaki fragments are still fragmented. They need to be connected by something. So the DNA polymerase 1 comes back in and removes the former primers that were there and replaces it with DNA.
The next step is that all the little nicks need to be sorted out, and this is done by the ligase. What the ligase does is it essentially clips together the parts of DNA that were fragmented and brings them together, as demonstrated by these clips. And now we have two completely new strands of DNA.
One compared with this one, and then two paired with this one.